All right, guys, Mr. Jenkins here with lesson 6.3's notes. This is our last lesson on how to, on a separate method of how to solve systems of equations, okay? This lesson focuses on what they call the elimination method, and this would be my favorite, I would think, of all of them because it's kind of easy to show your work if you understand what you're doing. Our learning target is to be able to solve systems by adding or subtracting to eliminate one variable. And that's kind of you'll notice that that's kind of what we do with substitution too. When we make that initial substitution, if you look back at 6.2, you end up with one variable. So that's the key, is to get rid of one variable. Okay. On that note, we will get right to it. Looking at 1A, it says solve each system using elimination and check your answer. Well, we know how we're going to check our answer, and actually we're going to check our answer before we do any work by inputting into Desmos. So it says 2x plus 5y equals 17, and 6x minus 5y equals negative 9. Okay, at that point, we're going to see where they cross. I'm zooming in because I'm way zoomed out. Okay, that looks a little better. So it looks like they cross at 1, 3. Let's just make sure. So there it shows, 1, 3, right? So I know right off the bat that my solution is, x equals 1, y equals 3, okay? But again, for full credit, I gotta be able to show my work, okay? So what we need to do is always eliminate one variable. Notice on these examples, 5y and negative 5y make 0. Negative 3x and 3x make 0. Negative 6y and 6y make 0. So these are all perfectly set up for elimination. In other words, all you have to do is add the two rows together, and one of the variables is going to go away, okay? And that's all we're doing, is we're adding them together. So 2x plus 6x is 8x. 5y minus 5y is 0. You can put plus 0 there. I like to just mark those out. And then equals 17 plus negative 9, all right, or 17 minus 9. So that gives me 8x equals 8. That's a simple one-step equation where we get that x is equal to 8 divided by 8, which is 1, which jives with our answer, so that's always good news. Step 2 is the exact same as it is on substitution. We can use our first variable to find our second variable. In other words, we can sub in 1 for x in either equation, and that should give me 3 for y. So let's just sub into this top equation. So we have 2 times 1 instead of 2 times x plus 5 times y equal to 17. So this is just equal to 2, so I'm going to subtract 2 from both sides. That's going to give me 5y equals 15, because 17 minus 2 is 15, and y equals 3, because 15 over 5 is 3, which matches that answer, okay? So again, we kind of work backwards. We check our answer first, and then we, get the work that goes with it, provide the work that goes with it for full credit on our test, okay? I'm going to leave B, C, and D for you guys, and you can ask about those in class. If you try one and you have questions, definitely feel free to ask about that in class. All right, looking at example 2, it says solving a system by subtracting, okay? So any of these, there we have x and x. Here we have 2c and 2c. And here we have negative 7y and negative 7y. So they are not perfectly set up for substitution, but they're very close. I'm going to look at B just because we're using the variables c and t. Okay, I guess we'll find out together if that works in Desmos. I just didn't want you to be confused with x and y. Okay, so let's go ahead and start there by inputting those equations into Desmos. And I'm going to try using the variable c and t. So 2c plus 3t equals 130. And then, let's see if it makes it right. If I 2c plus 5t equals 190. All right, it does look like it's going to make you use x and y, so that's why I wanted to show this one. So what we'll do just for Desmos purposes is make this first variable be x and the second variable be y. Okay, so we'll replace those c's with x's. Just make sure you're consistent. And then we'll replace the t's with y's. All right, now that should give me something that I can work with. It does appear to be off of my screen, and we know in that case we would need to zoom out. Zoom out a little bit so we can see that point of intersection. Okay, so we're getting close now. All right, so there we go. Looks like 20 comma 30, okay? So on this, since we're using C and T, we would probably want to say C equals 20 and T equals 30. And I know that 20 is my C coordinate because I used X in place of C. Okay, so I know my answer. Now I'm going to provide the work that goes with it. Okay. So you'll see in the next example that we could eliminate the t's, but the c's are going to be easier, okay? So they say subtracting. I like to think of this as just times -1, and then I add. So what I'm going to do is multiply this by -1, okay, and then I'm going to add them together. So I'm going to do plus -1 times that equation. So all that does is it flips all the signs, okay? So basically, you need to ultimately probably be able to see this in your head, but it turns this into equation into -2c minus 5t equals -190, okay? So 2c minus 2c is 0. 3t plus -5t is -2t. And then 130 plus -130 or 130 minus 130 is -60. And then -60 over -2 gives me t equals 30, which jives with that answer. And then we can plug that back into either equation. We'll just pick the bottom one, random, to verify that C coordinate. So that would be 2 times C plus 5 times 30 instead of T equals 190. So this would be 150. So when I do minus 150 from both sides, I get 2C plus 0 is 2C. And then 190 minus 150 is going to be, 40. And then C equals 40 over 2, which is 20. That also jives with that. Now we have a good answer and work that goes along with it. Okay. All right, out of this next example, I may show another one in class, but for the video, just to keep it relatively short, I will just show one, for now. Okay. So let's see. Are there any funky equations or answers? Not really. All right. Let's just do the first one then. 3a. Okay. So we'll start by checking our answer first. Okay. So I'm going to punch that in. The equations as I see them written. All right, so top equation is -2x plus 15y equals -32. And then the bottom equation is going to be 7x minus 5y equals 17. All right, and I can see where they cross there. I could zoom in a little bit. Why don't we do that just so we're not confused? Because sometimes if you're not careful, you can hover over the y-intercept instead of that point of intersection. So I suggest zooming in as much as you can, just so we can be sure we're over the point of intersection. So that's 1, -2. That's going to be our answer. All right, so again, we know our answer is x equals 1, y equals -2, just based on the graph. Now the key is how can we show the work? All right. All right. So what we would want to do is we're looking, which is going to be easier to make -2 and 7 opposites, or 15 and -5 opposites. All right. And the answer is 15 and 5 because 5 goes into 15. Right. So what we'd want to multiply by is 3 on the bottom, okay? So I like to be, if you can do this all mentally, that's great. But until that point, I'd go ahead and probably rewrite both of them. But you don't necessarily have to. So that's going to give me -2x plus 15y equals -32. Over top of, now I'm going to distribute my 3. So 21x minus 15y equals, and then 3 times 17, obviously just use your calculator there so you don't mess up, 51. And this should be -32. I wrote 32. So be careful with those signs, obviously. All right, so -2 plus 21 is going to be 19. So we got 19x. 15 plus -15 is 0, so that cancels. And then -32 plus 51 is going to be 19. And then 19 over 19 is, of course, 1, which goes with our answer. And then we just use that 1 to show that y is -2, hopefully. So let's just sub into the bottom. So that'd be step 2. Be 7 times 1 minus 5 times y equals 17. So first step would be -7 to both sides. That would leave me with -5y equals 10, because 17 minus 7 is 10. And then 10 over -5 tells me that y is -2, which again, we already knew, but now we have the work that proves the answer. All right, and now your hardest kind of problem are going to be like example 4, where we have to multiply both equations. So this is kind of like, coming up with a least common denominator, okay? That's going to be your thought process, all right? And there's more than one way to do it. So, well, I'm getting ahead of myself. Looking at 4a, we will start with the answer, and then we will go from there. All right, so my top equation on 4a is 3x plus 2y equals 1. And then we also have 4x plus 3y is -2. All right, so looking at my screen, it looks like they're gonna cross, but I'm gonna have to zoom out a little bit to see exactly where they cross. I'm a little bit too zoomed in here, so zoom out. Looks like they cross right there at 7, -10. So we understand that that's our answer going in. Now we want to try to provide the work to go with it so we can get full credit on our test answer. 7, negative 10. All right, so again, think lowest common denominator, right? So you can work with 3 and 4. You could work with 2 and 3, okay? So what's the lowest number that 3 and 4 both go into? That would be 12. What's the lowest number that both of these go into? That would be 6. So since 6 is lower than 12, I'm going to try to eliminate the y's, okay? It would not be wrong to eliminate the x's, but I'm going to eliminate the y's, all right? Also notice that they have the same sign, so one needs to be positive, one needs to be negative, okay? So what I'll do is I'll multiply the top one by 3, which is going to give me 9x plus 6y equals 3. Let me let that pop up. And then the bottom one by, so I have 6y, I want that to be negative 6y. So I need to multiply the bottom one by negative 2. And then I'll be ready to add them. So that would give me negative 8x minus 6y equals 4. Because negative 2 times negative 2 is 4. Now we're ready to go ahead and add them together because we have 6y and negative 6y. Okay? So 9x plus negative 8x, or 9x minus 8x is 1x. These cancel. And then 3 plus 4 is equal to 7. Notice that my coefficient is 1, so I'm already done. That matches with my answer. And then I'll just use that fact to prove the fact that y is negative 10. So let's just plug that into the top. So that'd be 3 times 7 plus 2 times y equals 1. So first step would be to move this over. That's 21, so I'm going to do minus 21 to both sides. That's going to give me 2y equals negative 20. And negative 20 over 2 gives me that y is negative 10, which is good news. We know we have the right work. All right, I'll probably show one more of those, and because those can be a little tricky. So we'll look at one more. Okay, so just to save a little bit of time here, I'm going to tell you on C, since I've shown this several times, that what you get when you punch this into Desmos is that they cross at 0.28 comma negative 0.08. So 0.28 comma, and that'd probably be one where you'd have to zoom in, right? Because those are both small numbers. And negative 0.08. All right, so let's see if we can come up with the algebra that goes with those weird answers, okay? So, 3 and 8 both go into 24. Those are both pretty big numbers. 2 and 3, again, both go into 6, so let's work with those. Also, with the y's, notice that one's negative, one's positive, so that's always nice, too, if you can get that, okay? So we're looking for a negative 6 up here, positive 6 down there for y. So I'm going to multiply the top by 3, which is going to give me 9x minus 6y equals 3. And then the bottom one by 2, which gives me 16x plus 6y equals 6. All right, so when we add them together then, which we're ready to do, we get those two make 25x, negative 6y plus 6y cancels, and then 3 plus 6 is 9. So x is equal to 9 divided by 25. All right, when you do 25 divided by 9, 9 divided by 25, you get 0.36. Let's see, I did something wrong there. 3x, 9x minus 6y equals 3. 16x plus 6y equals 4. Which gives us 16x plus 6y equals 2 times 2 is 4. Now we're ready to add them together, and we'll get that cancellation we're looking for. 9 plus 16 is 25, so we have 25x. We have 0y, and then equals 7. And then when you punch in 7 divided by 25, you're going to get that 0.28. If you needed a fraction, you would just leave it as 7/25. Okay, and then you could just punch that in either right there, and solve to get for y, which should be negative 0.08. Okay, so I'm going to skip over that part just to save a little bit of time, but I wanted you to see that one because it was a little funky. All right, last ones, number of solutions. So these are going to be IMS or no solution. So let's recall what that looks like on the graph. So looking at 5A here. We got 2x plus 6y equals 18. And then we also have x plus 3y equals 9. Okay, and then when we look at them, they appear to be one line, right? You might zoom in just to make sure that they're not real close together, but they do appear to just be one line. There's no space in between them. So this looks like an IMS. Again, you type in 2 equations, you get the same line. That's going to be IMS. Infinitely many solutions is what that stands for. And now, how can we just prove that algebraically? So let's say we want to cancel the x's, then we'd multiply by -2. So when we do that, we have 2x plus -2 times x, so that'd be 0. We have 6y plus -2 times 3y, so that'd be 6y minus 6y, that'd be 0. And then on the other side, we have 18 plus -2 times 9, that's 18 plus -18, that equals 0. Okay, so that equation is true because 0 equals 0. So that's what an IMS looks like when you're doing elimination. Okay, so the next one, if you type in -2x plus 5y equals 7 and -2x plus 5y equals 12, you are going to see lines that are parallel, okay, that run side by side, that never cross, no matter how far you zoom out. So that's going to be a no solution. And so let's go ahead and just add those together and see what happens. You do have to be careful with am I adding or am I subtracting? Okay, so here you can think of I'm adding. I prefer to think of as I'm adding after I distribute a -1. In other words, you need to flip all these signs before you add, right? Because -2x plus -2x is -4x. So I'm flipping the signs here. So I have -2x plus 2x, that's 0. I have 5y plus -5y, that's 0. And then I have 7 plus -12, that'd be -5. So you see the similarities are both variables went away. The difference is I don't get the same thing on the other side. So that checks out with a no solution, okay? This is kind of a long video, but you know we'll be kind of on this stuff for a couple days. So make sure that you ask questions if you have some, and hopefully this helps.